In this video, I want to talk about how to divide rational expressions. So again, before we start, let's review how to divide fractions. So let's say I had 3/4 divided by 6/5. What you would do for dividing fractions is you would keep your first fraction the same. We change to multiply. And then remember, we always took the reciprocal or flipped that second fraction. And then what you do is you multiply from here. So you just use your regular multiplication skills. Remember, we multiply straight across. And then you can also cancel factors in common. So you may notice that 6 can be broken into 2 times 3. So that factor of 3 would cancel out. And then you're left with just 5/8 for your final answer. So we change our original problem to multiplication, making sure to flip or take the reciprocal of that second fraction. And then we just multiply and simplify as we normally do. And we're going to apply that same technique here to rationals. Oops. There's my example. So let's say I have something like this. X plus 4 over x minus 1 divided by 1 over x squared minus 1. So think back to your regular steps. We're going to keep the same one, the first one the same. We're going to change this to a multiplication problem, and then you are going to flip that second fraction. So whatever is in the denominator comes up, and whatever is in the numerator goes down. Now at this point, it's going to be the same thing as multiplying, but again, think about factoring here. It's usually easier to factor first. That's what I like to do. I'm just going to move over here so I have more room. Now, the first part I can't do anything with, but I can definitely factor that x squared minus 1. That becomes x plus 1, x minus 1. And now I can multiply straight across. Now, for me, I'm not multiplying anything out just yet, right? I'm just rewriting everything. X minus 1, and then I don't really need the multiplying by 1. Multiplying by 1 doesn't change anything. So here my x minus 1's cancel, and I'm left with x plus 4 times x plus 1 as my final result. Now remember, we can often leave our answers in factored form, so I'm just going to leave it factored like this. If I have nothing left in the denominator, that's fine. It would just be a 1 there. We just have to be careful. If you have nothing in the numerator, you would definitely want to put that 1 in as a placeholder. But a 1 in the denominator doesn't matter because dividing by 1 doesn't change the problem. All right, let's talk about our domain here. Now, I don't see any domains here, any domain issues in my answer, but I definitely had fractions right at the beginning. So I do need to make sure that my first denominator is not equal to 0, and my second denominator is not equal to 0 as well. So here I need to exclude x equals 1. And then here we saw that this factored into x plus 1, x minus 1. So we're excluding -1 and +1. Oops, sorry about that, guys. So I actually only have 2 unique values here. I have a +1 and then a -1, right? This one we already have. So I have 2 values I have to exclude. There's one thing you have to watch out for with dividing rational expressions. You also have to make sure the numerator of the divisor, which is the second expression, is not 0. Okay. Now, in this case, my numerator of my second fraction was just a 1, so it will never be 0. Okay, so I don't have that issue here. But the reason we have to check that as well as our denominators, in this case, it's only for dividing, is because when we divide by something, we can't divide by 0. So I have to also worry that the overall fraction would be 0 too. So it throws in an extra kind of restriction you have to watch out for. So when you're checking domains, for rationals, you always check all your denominators. But for dividing, you have to also check the second numerator, whatever the numerator is of your divisor, because you don't want that to be 0 either. That would mean that you're dividing by a 0 as well. So we do need to watch out for that. Here, I don't have that issue. So I only have to exclude 2 values here. So I'm going to exclude -1 and +1. And this time I'm going to use interval notation to write my domain. All right, let's do another example. So we're going to leave our first fraction the same. We are going to change the multiplication and we are going to flip our second fraction. So the x plus 3 goes up and the x minus 4 goes down. And now I would factor. So my next step is going to be to factor. So this part here, let's see, we're going to factor as x plus 2, x minus 4. And then in the denominator, this is going to factor as x plus 3, x minus 3. And we're multiplying that by x plus 3 over x plus 4. So just rewriting this straight across. Here, again, this is one factor, so I am going to put it in parentheses. And I'm going to go ahead and cancel what's in common. So I have an x plus 3 in common here. And, oops, sorry, I wrote this wrong, guys. I apologize. This should have been a -4. Sorry, see how it was a -4 there? I wrote it wrong. Should have been a -4 and a -4. And then now these will also cancel. You don't always get that everything cancels in a rational problem, but for most of the questions, because we create them, you're going to see that a lot of things do cancel, which is why I kind of went back and said, huh, that's kind of weird that didn't cancel. And I realized I wrote it wrong. So double check your work here, because you'll find that in most cases, you're going to get some good canceling. And I'm left with just x plus 2 over x minus 3. Now, again, let's look at our domain. So I have my original denominator, so I need to make sure x squared minus 9 is not equal to 0. I also have this one right here, right? My x plus 3. I have to make sure that's not 0. And I also have my denominator here. So if I have any denominators, that should be your first step, is making sure none of those values are actually 0. Now this factor, so you actually get 2 factors here that you have to worry about not being 0. And you're going to actually see some repeats, right? So I have to make sure that x is not equal to -3, x is not equal to +3 from the first part. And then actually we're going to get the same results here. When I subtract 3, I get the -3 value again. When I add 3, I get the +3 value again. So I don't need to write them in more than once, but I am checking all my denominators. Now with division, don't forget, you also have to check the numerator of your divisor only. So your divisor is your second one. So this is the one that I have to check. So I need to make sure that x minus 4 is also not equal to 0. Add 4 to both sides, and x is not equal to 4. So that is a third restriction here. And again, that is unique to dividing. not to the other operations. And it's because where we're dividing here by this, I need to make sure that this value is not 0 as well, because then I'm finding another way to divide by 0. So there's lots of ways that we could get 0 when we're dividing. So we need to exclude that value as well. So our domain here, I'll use set notation this time. X cannot be -3 or +3 or also 4.